Alright, here's a quick demo of the current meter. So, this is it. This is the analog part of it. And of course, it's hooked up to the dash. And here's a split core transformer. And you can see, actually, I have it around an extension cord here. And I've got this heater plugged in. This is a 1500 watt heater. So it'll draw a lot of current. But you can see, actually, I wrapped the wire around it twice. But you can see that the wire needs to be split like that. I only want it to go around one of the conductors. So I have it wrapped around twice to amplify the current, because this is actually this is a pretty small current draw relative to application. So this has two potentiometers. So there's one on this side, and this is a sensitivity. So if the power coming in is the voltage is too high, you can actually dial this down. I don't think that we'll need to use this, but in some applications you do. And this is kind of just the calibration, so we can kind of do a fine control. So you want this basically as sensitive as possible, and then you want to kind of dial this in to be in the right range. So the idea here is that you can dial these two potentiometers such that when I turn on the power, you can see that light comes on. And now I'm turning it off, right, and the current goes down like that, so it turns off. So you want it so that the LED is off until the current is being drawn, and then the LED will come on. So that signal gets sent to the dash, and so I can show you what's going on in the dash here. So we've got, these are the raw values coming in. So I'll turn on the heater now. And we can see that we start getting this history count. So the history count is how many, every half second it records a value. You can see the baseline value there is like 60, 70. And this is level 1. And actually I turn the heater up to high. You can see that these values go up quite a bit. So they're 400, and then on high it's like 1,000, something like that. So once the history count goes above 20, that will be considered a data point, and that will be sent out. So as long as we have more than 20 history points here, when I turn the power off, you can see I turn it off, and I turn it off for just a second. If I turn it off for just a second, it'll kind of resume and pick up where it left off and continue recording that as one block of records. But if I turn it off, and it stays off for more than 2 seconds, you can see I get this big long line of all the data points, and then that gets sent out to the cloud. You can see it was sent out to the cloud there. So now if I check in the cloud, I see that I have one new log, and I get a time, and this is the time the last data point came in, so you can work backwards at half-second intervals from the last one and figure out the exact moment of all of these data points. We also send the battery level, which right now we're running on power, USB power, so it says 204, which doesn't obviously make any sense. But when this is running on a battery, we'll have an idea of what the battery level is. And this is the cell signal strength as well. So that's pretty much it. I'm going to put together some documentation for calibration here. One other thing is that there's this right here. So we can actually pull this off, and if we pull this off and we turn on the heater for a while, it still collects data. Let's see here, we've got data still being sent. But if I turn it off, it will dump the history, but it doesn't send it to the cloud. So if you're going to be doing calibration, that kind of thing, then you want to keep this off. But when this goes live and you want to actually send the data off to the cloud, once you've figured out all the calibrations and you've set these two potentiometers, then you can take this little jumper and put it back on, and it will send the data off to the cloud again. So that's the basic operation, and this will kind of give us an idea of what level to set these two potentiometers so we get the best readings possible.